Okay, so for today we're going to look at the remainder theorem and how we can use that. So this is the remainder theorem. If a polynomial f of x is divided by x minus k, then the remainder of is r is equal to f of k. So this is saying if you were to take this k, right, and you are going to go ahead and plug this k into your function, then when you evaluate it, it's going to equal your remainder. So let's see how we can use this theorem in this problem below. So the directions say we have to use synthetic division. That's something that we did yesterday. And we need to evaluate the function for the indicated value of k. So we have to evaluate the function. So what they mean is by evaluating the function, right, for the indicated value of x, this is our function, and this is the indicated value of x. By evaluate, we mean what's going to happen once we plug in -4 for this whole function. Now we can go ahead and start substituting this function like this, but what's great about this remainder theorem is that it gives us another shortcut, so we don't have to do all this work, right? Now, so I'm going to set up my synthetic division. Usually for problems like this, this would be our divisor, and it's usually written something like this. But here they gave us the question as x is equal to -4. These two is going to be the same thing. So we're going to write this -4 outside, and inside over here we're going to write again our coefficients for our coefficients and constants of the polynomial. Now what's great about this polynomial is that your powers are in order. Nothing's missing. 3, 2, 1. So I don't have to put in an extra 0 anywhere. Nothing was skipped. So I'm going to write 5. I'm going to write -1. I'm going to write 13. And I'm going to write 29. All right. So now just like yesterday, I'm going to bring down the 5. And then I'm going to be doing -4 times 5, which is -20. And I'll put the -20 right under the -1 because I'm going to add. So on the side, I'm actually doing -1 plus -20, and that'll give me -21. So -21 I'm going to write down here. Now, at this point, I'm going to go back into multiplying. Let me write the multiplying stuff right over here. So I'm going to be doing -4 times -21. So on this side over here, -21 times -4. And remember, a negative times a negative is a positive. And that's going to give me the positive 84. So I'm going to put that 84 right here. And remember, on these over here, we're not going to be subtracting, we're adding. And then we have a 97. Right? So we did 13 plus 84. That gave us a 97. And the whole process is going to restart again. So I'm going to take -4 and I'm going to multiply it by 97. Remember, a negative times a positive, that gives you a negative. and you're going to get negative 388. So this one I'm going to write underneath the 29, and I'm going to add it. So I'm going to add 29 plus negative, whoops, that's supposed to be an 8. There you go. Negative 388. And if I use my calculator, this is going to give you negative 359. All right. So now, usually when we do synthetic division, our last number, this is going to be our remainder. And if we use this remainder theorem up here, this is saying your remainder is going to equal to the function when we plug in the value of k. In this case, our function, when we plug in the value of negative 4, we're going to get this answer right over here. And that's our answer. And if we were going to go ahead and check our work, we can start plugging in everything. So right over here, 5 times 4 times 4 times 4, that would give us 320. And then here we have negative, so we have negative 4 squared, same as saying 4 times 4, which is a positive 16. Because a negative 4 times a negative 4 is 16. But because there's a negative sign there, we're going to put 16 over here. Plus 13 times 4, 52, plus 29. So we put all of these together. Oh, this would actually be a negative, because over here you're doing negative 4 times negative 4, negative 4. And like I said, if we put all of this together, we're going to end up with negative 359. Right? So instead of doing all of this work, we just put all of our work into this synthetic division, and we get this solution right over here. And this was all thanks to the remainder theorem, which helped us to just go ahead and use this shortcut. Right? So for the problems of this week, you're going to be using your synthetic division to evaluate the function. So I want you to do the method just like this. And you can go ahead and check your work, but this is the method that we're using.